Hi, today we're going to be going over some web jargon that is commonly used in the web development industry. It's a bit fast-paced when you first start on a web developer job in the worst of cases. Consequently, knowing these terms will help prevent confusion. I remember when I first started, I got a little bit confused. The more you know, the more I'll help you later on, and I want you to be in the same situation as me. So yeah, let's go through it. It's a short lecture, but it's very high yield. Okay, so get ready. Hi, so let's learn about some web developer jargon. The first term that we'll be covering is responsive website. A responsive website is basically a website that reorganizes and is still usable despite what type of device you view it on and screen size you view it on. So for example, you should be able to view it on a regular laptop as usual. And if you look at the website on a phone, the website will also still be usable. The reason why this has become important in recent years is because there are more people viewing websites on their phone than on their computers as of today. Thus, if you make a website user-friendly and viewable on a phone, people are more likely to use it and come back to use it. So let's look at an example. Okay, so this is an example of a responsive website. As you can see, with the regular screen size of my laptop, it looks normal. However, if we were to shrink the screen of the laptop, of the actual browser, we could still view it, and the actual page structure has changed to still be user-friendly. And this is what is meant by mobile responsive design. To show you an example of what is not responsive design, we could shrink the Yahoo search page, and it will not reorganize based on the size of the screen. There are workarounds for that. In the past, they would have specific websites that would show up if you're reviewing the website on a mobile device versus a regular PC. But that's double the work because you're creating two websites essentially. A responsive website is one website that reorganizes its elements based on what screen size you're viewing it from. The next set of terms I want to cover are HTML, CSS, and JS. HTML stands for Hypertext Markup Language, CSS is Cascading Style Sheets, and JS stands for JavaScript. So let's go and take a look at what the internet says about these terms. So let's type in HTML. So HTML is the standard markup language for websites. With HTML, you can create your own websites. HTML is easy to learn and you will enjoy it. So if all websites are made out of HTML, we should be able to see it, right? So on a website, right-click in your browser and go to View Source. Depending on your browser, you might actually have this somewhere else, but it exists in all browsers that I'm aware of. So click View Source. And suddenly, we get a tab with all this interesting markup. These tags and text are what HTML is composed of. It is assisted by technology such as CSS and JS, which is HTML alone isn't enough to make a website look pretty. So Cascading Style Sheets, or CSS, was introduced in order to allow for better manipulation of how the data looks in the browser. And JavaScript allows for dynamic behavior and interactive behavior of the user with the website. All those three technologies run on the client's browser. The next term I want to cover is protocol. A protocol is basically a language spoken over a network. And we'll get to the definition of what a network is a little bit later, but it's essentially a group of computers that are connected together and can talk. So in order for two computers to talk, they have to speak the same language. For example, a Chinese guy that only knows Chinese can't communicate with the English guy that knows only English. This applies to applications and programs and processes as well. So if you have two different applications that don't speak the same language, you're not going to be able to communicate with each other. This is what a protocol is, a language of communication over a network. So now server-side programming languages. A server-side programming language is a programming language you write code for that runs on your server. And a client-side programming language is a programming language that runs in the browser of the computer that's viewing the website. An example of a client-side programming language that we just saw was JavaScript. So let's look for an example of, in this website that we just viewed, of CSS as well as JavaScript. So if we look over here, we see a style tag. Within that style tag is CSS code. And sometimes people include it as links. So if we look up and we'll see link href is equal to this. This is also an example of CSS that's been included on the website. Okay, see, that is CSS code. Now let's find some JavaScript. If I right click on this website, SQL Server Sapphire, and view the source, we see, okay, let's check another site. Let's look at what we were already looking at. For some reason it's not showing up. Okay, so we see a script tag over here, and it says type equals text equals JavaScript. So this code within the script tag is actually JavaScript code. And as you can see, it's structurally different from CSS and HTML, but together they work in conjunction to provide a more dynamic and a visually appealing experience for the user viewing websites. Okay, so on to the next slide, and we'll see some work key terms. And the new term of interest is network. A network is basically a bunch of computer components connected together that can communicate. The internet, for example, is a super big network because it's a bunch of computers and computer-like devices that communicate. A subnet is basically a smaller network that connects to the internet. Packets are basically words that computers use to talk over the internet. So think of protocol like the language of the internet, and the packets are like words. So every time a computer has a message to send to another computer, it splits up that message into smaller parts and sends it over the network. Each packet has a source and destination IP associated with it. IP address. An IP address is a numeric or hexadecimal string that is the address of the computer on the internet or connected to a network in the form of what you can see on this slide, or the hexadecimal form. Initially, around 10 years ago, all the IP addresses were purely numerical. However, they ran out of them. So in order to allow for more computers to connect to the internet, because it's grown so massively, they came up with this hexadecimal format, which is called IPv6, version 6, that allows for more computers to use the internet. Basically, what an IP address does is tell packets what paths to take in order to get to its destination computer. Every packet that is sent over the internet has a source IP address and a destination IP address associated with it. That tells it where it's coming, tells the computer that receives it where it's coming from, as well as tells the routing mechanisms on the internet where it's going. A port is basically a communication endpoint for packets. It can be physical or logical and is used by applications to communicate with other devices. You view websites over port 80 usually, but this isn't important for now, so I won't go into that. A gateway is basically a device or IP address that all packets pass through in order to leave a subnet. So if we were to actually look at an example, let's open up our command prompt and type in ipconfig. As you can see here, we see our IP address and we see the default gateway. So if I'm sending information to the internet, it's passing through this IP address 10.2.0.1. But this will all make sense more as we get into developing the web application and things like this come up. But for now, just keep in mind that they exist. The next term you should be aware of is router. Basically, a router is a device for connecting computers to the internet. So if you're on a network that you set up in your house, the router is what's going to give you access to the internet. It's usually provided by your internet service provider, the people that you order internet from, and is a physical device that you can see. A switch is a device for connecting several computers together in a subnet. So oftentimes routers and switches these days have been merged into one. However, the pure definition is a switch is for connecting, like in your company would be a physical device for connecting all the computers and allowing them to communicate with each other, but it doesn't necessarily give you access to the internet because it usually works within a subnet. A router is the device that gives you access to the bigger network. Firewall is a device used to control what comes out of your network or your computer and goes in terms of network traffic. It can be hardware or software. A client is basically a computer that is used for browsing the internet, and a server is the computer that stores the website and presents it to any computers that are want to view it on the internet. And finally, bandwidth is basically how fast your computer can send or receive data over a network. Okay, so let's pretend Dora is you and your computer is a client because you're viewing a website. Let's say you're viewing yahoo.com on your computer and you're browsing over the internet to look at the yahoo.com search page, and you send a signal over the internet to a server computer that sends the actual website back to your computer so that you can view it. An issue occurs when too many people are requesting access to that same page, because in the past, websites were hosted only on a single computer. So when the amount of traffic on the internet was low, this was okay. However, as it increased, what was found out was that a single server wasn't able to keep up with the demand of all the requests and send back all that information. So at times when it got overloaded, it would just stop responding to all the requests and would perform unusually slow, or even crash in some cases. So two terms that came up in order to deal with problems like this were computer network architectures that utilize. What I mean by architecture is arrangement or a setup of servers or how something is built. So what they did is utilize something called mirrors, where they would have several computers hosting the same website, and if there was increased demand, it would spread out the demand of those requests amongst several of the computers and send back a response so that it could better handle a lot of requests. But there were still challenges associated with that, because if you think about it, if you're downloading a file, you have a limit on your bandwidth, so there's only so fast that you could download it. So if you have a network that doesn't have a high bandwidth, even if your computers could handle all the requests coming to it, it will only be able to send back so much data. So a solution was to buy a larger bandwidth so that all those actual websites can be hosted and sent back to a lot of computers. But that was still complicated, because back then you'd still have to have that set up. There would be a lot of administrators you'd have to hire, in order to monitor these servers and make sure everything was functioning as planned. So this is why the cloud was invented, which is basically a company that has a bunch of computers that allow you to use their computers, and they also preemptively have a lot of bandwidth, and they set this up and built out this entire infrastructure themselves, so that you won't have to worry about hiring administrators for monitoring the hardware and the actual computers. You just have to set it up, and then they would handle the rest. So that's what the cloud is. It's basically an infrastructure or a large amount of computers that you could put your website on, and you don't have to worry about things like bandwidth or hardware or hard drive space, because it's all taken care of for you. Mirrors was separate servers or computers that hosted websites, and it would bounce off. You would separate the requests between the different computers of the people that wanted to view your website, and they would send it back. You could even have mirrors on the cloud in case, because since it is technically a computer, if one of the sites goes down or is inaccessible from another country, you could have a mirror of that cloud website in another country's cloud server, so that'll be accessible from there. But we're not going to get into that. I just want you to be aware of those terms. And yeah, that's it. That was a bit of a dry lecture, I know, but those terms will come up again and again in your web development career, and rather than be confused, at least you know it now. So let's get to more